Hello, my name is Ravi Sinha. First, I thought it'd be important to talk about the process for which we're going to develop and produce our final design. Our project deals with Fourier transform infrared spectroscopy, a term which I was not familiar with prior to this project, nor was anybody on the team really familiar with the technology or the math behind it. So we thought it'd be a good starting point to simulate the raw data in MATLAB, perform the transformation calculations in MATLAB to get an understanding of how the calculations work, and just to get an overall feel of the process. Once we have the algorithms down and have an understanding, we're going to put them into Java, the programming language of the Android smartphone. We then use those algorithms in the Java to create a smartphone application, the user interface that the user will see on the actual smartphone, Google Nexus S. We'll then be able to optimize the algorithms to increase battery life, decrease processing time, while still maintaining the level of accuracy required by the sponsor. This is a representation of our final design in UML, Uniform Modeling Language. The smartphone will be what the user sees. This is a representation, I don't know if you guys are familiar with Uniform Modeling Language, but a representation of the actual program. Each one represents a class and the associations with it. We're going to utilize the object-oriented nature of Java programming to contain each type of data, whether it's the raw data, the transform data, or the spectral library, in a separate class, and have each functions associated with that class and that type of data. The sensor side, as that's prior, will actually be a stand-in sensor, so no one have access to the real sensor. Will be a smartphone. It'll be the only thing on the smartphone will be a very stripped-down communications program. It'll respond from requests from the smartphone and send the raw data. Because this is very much a proof of concept from Mattel, they wish to have multiple methods of transmission between the sensor and the smartphone. So we'll be providing them with two: Bluetooth transmission and wireless internet transmission. There are benefits and cons to both, and we hope to provide them with the results. The risks associated with this project vary greatly with the goal of the project. With regard to the analysis of current smartphone technologies and predictions of future smartphone technologies, an accurate information is critical. Smartphone manufacturers are very willing to give us the information of the current smartphones. In fact, they use it as a marketing tool, give you the latest and greatest phones, and you'll go and buy it. They're not so forthcoming with future technologies. This is for reasons that A, they want to keep it a secret, they want to stay competitive, and two, they might not know what those technologies are going to be. They don't want to overpromise, and they don't want to speculate. So the best is we can give a prediction. The farther out the prediction we give to Mattel, 2, 3, 4 years, will definitely increase. The risk will increase if the predictions will be inaccurate. With regard to using the current smartphone technologies to control and advanced sensor systems, we as a group feel fairly confident that it's possible. We know the results can be done on the phone. It's not a matter of if it can be done, but how fast it can be done. We may be able to get results in a matter of minutes, where the sponsor is looking for results in a matter of seconds. And then, even if we are able to produce results in a manner of time that is acceptable to the sponsor, it might only be on the highest phones, the ones with the 1 gigahertz Hummingbird processor, which is the highest end phone right now, or one of the highest end phones. So it might make it financially practical for them to remove the onboard sensor and use a smartphone. Our budget is actually pretty straightforward for this project. We only anticipate one cost, and that is the Google development phone and the Android Nexus S. It's $530. The software development kit for Android is actually freely available on the web, so there was no cost associated with that. With regard to the stand-in sensor, we're fortunate enough for Shanta to loan us an older phone that we're going to use, so there's no cost associated with that. So our total cost is the cost of the Android phone. We hope to provide Mattel with two things. One, a current analysis of future predictions of smartphone technologies, especially with regard to controlling advanced sensor systems. And two, a working model so that to prove the proof of concept that sensor systems such as these infrared Fourier transformers can be controlled by smartphones. More than happy to take any questions. Yes?
Yeah, so why don't you implement part of this library in C on the smartphone, or C++? Is that why C++ instead of Java?
Java is the operating system of.
Well, no, there is a Java native binding. So you can use the JNI to interface between the virtual machine running C code. Because I mean, like, so the Fourier transform algorithms are running in Linux, and the data you collect off the sensors there are just gonna like beat your Java app up, right?
We've actually
because it's running on a VM and it's GC collected, right? So
We've had pretty good performance right now. We've got the Fourier transfer down to within 2 or 3 seconds.
Right.
And it's pretty large data. We're sampling about 4,096 data points. So it isn't too bad. We're really worried about the comparison of the spectra once we actually transform this, comparing it with the pre-populated library. That might be something to look into.
Yeah, I know. I just know it's people usually use JNI for this kind of stuff if they don't want to really get killed by the GC on the doll bit.
Any other questions?
No, I didn't get most of that.